Hey everyone, ready to dive into the world of engineering? Let's get started. Welcome to our deep dive into the fascinating world of capacitors. In this video, we'll explore how these essential components store and release energy, playing a crucial role in countless electronic devices. From your smartphone to electric vehicles, capacitors are everywhere, yet many of us don't fully understand their significance. We'll start by breaking down the basic principles of how capacitors work, including their ability to hold electrical charge and the factors that influence their performance. Next, we'll discuss the different types of capacitors and their specific applications, highlighting why they are indispensable in modern technology. By the end of this video, you'll not only grasp the fundamental concepts, but also appreciate the vital role capacitors play in ensuring our devices function smoothly. So, whether you're a tech enthusiast or just curious about electronics, stick around as we unravel the mysteries of capacitors and their impact on our daily lives. What is a capacitor? A capacitor is a fundamental electronic component designed to store and release electrical energy. At its core, a capacitor consists of two conductive plates separated by an insulating material known as a dielectric. The plates are typically made of metal, while the dielectric can be made from various materials, such as ceramic, plastic, or electrolytic substances. When a voltage is applied across the plates, an electric field forms, allowing the capacitor to store energy in the form of an electric charge. What sets capacitors apart from other electronic components, like resistors or inductors, is their unique ability to store energy temporarily rather than dissipating it. While resistors convert electrical energy into heat, capacitors can release their stored energy quickly when needed. This makes them essential for applications like smoothing out voltage fluctuations in power supplies or providing bursts of energy in flash photography. Understanding capacitors is crucial for grasping how electronic circuits function and why they are vital in our everyday technology. How capacitors store energy. Capacitors store energy through the process of accumulating electric charge on their plates. When a voltage is applied across the capacitor, electrons are pushed onto one plate, creating a negative charge, while the other plate loses electrons, resulting in a positive charge. This separation of charge creates an electric field between the plates, which is essential for energy storage. The amount of energy a capacitor can store is directly related to its capacitance, which is measured in farads. Capacitance is determined by the surface area of the plates, the distance between them, and the type of dielectric material used. The formula for energy stored in a capacitor is given by the equation E equals 1/2 on C V2, where E is energy, C is capacitance, and V is voltage. To visualize this process, imagine a simple diagram showing the charging of a capacitor, with arrows indicating the movement of electrons and the buildup of charge. Animations can further illustrate how the electric field develops, enhancing your understanding of this critical energy storage mechanism. How capacitors release energy. The energy stored in a capacitor is released through a process known as discharge. When a circuit is closed, the stored electric charge flows from the capacitor back into the circuit, providing a burst of energy. This discharge process can happen quickly, allowing capacitors to deliver power when needed, such as during sudden demands in electronic devices. One of the key applications of capacitors is in smoothing out voltage fluctuations in power supplies. By releasing energy during brief drops in voltage, capacitors help maintain a steady output, ensuring that sensitive components receive a consistent power supply. Real-world examples of energy release from capacitors can be seen in camera flashes, where a capacitor discharges rapidly to produce a bright flash of light. Similarly, in audio equipment, capacitors help maintain sound quality by providing quick bursts of energy to amplify signals. Understanding how capacitors release energy is essential for appreciating their role in enhancing the performance and reliability of various electronic devices. Applications of capacitors play a vital role in a wide range of everyday technologies, making them indispensable in modern electronics. One of their primary applications is in power supplies, where they help smooth out voltage fluctuations, ensuring a stable output for devices like computers and televisions. In audio equipment, capacitors are used to filter signals, enhancing sound quality by allowing only certain frequencies to pass through, crucial for achieving clear audio performance. Additionally, capacitors are essential in timing circuits, where they work alongside resistors to create precise time delays. This functionality is commonly found in devices like clocks and timers, ensuring accurate timekeeping. In signal processing, capacitors help in shaping and modifying signals, making them essential in communication devices. Innovative uses of capacitors are also emerging in renewable energy systems, such as solar power. Here, they store excess energy generated during peak sunlight hours and release it when needed, improving the efficiency and reliability of renewable energy sources. Overall, capacitors are integral to enhancing the performance and functionality of the technologies we rely on daily. In this video, we've explored the fascinating world of capacitors, highlighting their essential role in storing and releasing electrical energy. We discussed how capacitors function, from their basic structure to the mechanisms behind energy storage and discharge. Understanding how capacitors work is crucial for anyone interested in electronics, as they are integral to the performance of countless devices we use every day. We also touched on various applications of capacitors, including their importance in power supplies, audio equipment, timing circuits, and even renewable energy systems. This knowledge not only enhances your appreciation of technology, but also opens the door to further exploration in the field of electronics. That's all for today. Stay tuned to Tech Blueprint for more clear and practical engineering content.